All right. Oof. Sweet. Okay, so actually, I think I already.
What are you finding? Wow.
All right. Should we do this so that if you guys want to use this stuff, you can play with it? And I'm not going to talk too long about it, hopefully, but I just wanted to run through a couple of the things that I've been using the SF package a lot lately, and it's been really great. So I'm not. Whoa. So anyway, the SF package is so all the stuff that I'm going to cover today is at that website at brianpeak.github.io/mapping_in-r. And I'm on the mapping methods using SF, and I haven't quite finished this page yet, but it's a good place to start. So for simple features, and it works with vector-based data. So raster, you want to use the raster package. For vector stuff, any vector stuff, polygons, lines, points, anything, I would pretty much always use the SF at this point because it is much faster, like significantly so, in loading your points, writing, working with them, all that stuff. And they're transitioning a lot of the spatial sort of analyses and plotting software or packages to use SF objects. So most of R and spatial world is heading towards using this, the RGDAL format for good reasons, as you'll see. But let's just click on vignettes because I want you to know that the folks who have written this, Edzer Pebesma, is the main author. Among other folks, but they've written some really nice vignettes. So if you scroll down here, they've got 6 now. I'm just going to show you the first couple. And so the main thing is that they have basically taken all the way R used to read spatial data in was based on sort of a standard that was not used more widely. So ArcGIS uses sort of a set standard of reading spatial data. QGIS uses the same sort of set standard, right? R did not use that, used a different format, which made it kind of a pain working between things. This has basically eliminated that and made it so it's a formal standard that by doing that, it makes it a lot faster because it removes a lot of the weird stuff that was happening. And then it also, the great thing is it just is reading everything in as a data frame. So when it reads in a shapefile of any kind, or when it creates a shapefile, it makes that a data frame, a regular data frame that you can work with. The only difference in that is that the last column, which we'll see an example, is a list column. So it's basically a list. It's a single column, but it actually has a list of stuff in it, spatial information. So if it's a polygon, it'll be a list of like the whole ring of the polygon, a line, whatever it is. It's all in one column. And the great thing is that means you can operate on a data frame as you would any other data frame. You can join things, you can subset, filter, query, do all kinds of really great stuff really quickly without having to worry about the spatial stuff because it's associated, it's its own sort of list column within that data frame. That's the main benefit, I think, of this. One thing to consider is that this, again, this is for vector-based data. So points, line strings, polygons, multi-point, multi-line strings, and multi-polygons. they even have these things, they're kind of weird, called geometry collections. I haven't really used those much, but it works with, what's great is it works with all these types, just like ArcGIS does, and it reads in a whole bunch of different types of data. So it'll work with KML files. You can read a KML straight in from with SF. You can read, I'll show you a really cool trick I've found. You can actually read the zipped shape file in. So you sort of, if you keep all your shape files zipped, right, on your hard drive, and it's less of a hassle because there's not 9 bajillion files, you can read those zipped files. You basically unzip it and read it in all at once, and then it's just in your environment and you can work with it, and then you don't have to mess with having to sort of keep those files open and big, right? So that's actually been a really cool trick I've been using a lot lately. So where's I want to show you just what the types of data, here we go. So in Vignette 2, I think, here we go. This is the list of drivers that it will read from, and it basically will guess based on the extension. So it reads CSVs, GDB, so geodatabases, GeoJSON, GPS type data, so which is really cool. All these other pieces, NetCDF, it reads NetCDF data in, which a lot of climate stacks are in now. Shape, SQLite, XLS, X, and all those good things. So it also is being built in with a lot of, for folks that work with databases, it will read straight out of a database as well. So pretty powerful as far as what it covers. It really will read in just about any type of spatial data. And the other nice thing is it guesses based on the file extension, so you don't really have to, before you would have to say like what kind of file this is and that sort of stuff. This pretty much does that for you just based on the file. It looks at it for you. Okay, so if anybody is listening online and if you are chatting, I'll try to check the live chat over here. So feel free to chime in if people are online. Okay, so that is basically the sort of intro to this. And so there's a bunch of different types, how they are organized. So let's look at how a spatial features reads a spatial file in. So this is just a demo straight out of the vignette. So if you want to follow along and do this, I'm just going to show this web page. But essentially, if you read in the command to read in anything in SF is typically an st underscore command function. So let's open up a new script and just try this. So library SF, and then let's use their system file really quick. So if you're having trouble installing SF, let me know and we can troubleshoot that after. It can be a little tricky because you need to have the most updated version of RStudio and GDAL package. So anyway, we can talk about that later. So if I am, let's see if we make this bigger. Can you all see that? Mm-hmm. Okay. If I'm going to read this in, all I'm doing is st underscore read. And what's really neat is this works with st underscore read works with any of those data types. You don't need to like specify different. It'll figure it out for you. What's different is it's looking for this system file. I'll show an example that uses a different file in a sec. So if I run this, first I need to load the library. Okay. What you'll notice is what it spits out is right off the bat. It's really quick. It loads the shapefile, but then it spits out this this little kind of information, this metadata, which is really nice. And so this is always available. You can come back and look at it. But what I really like is it tells you the geometry type, the dimensions. So this is just XY data versus like line or polygon. And then it gives you the bounding box of the sort of the extent of your data. It also tells you the EPSG, sort of the code, the projection code right here, which is also really great if it exists, if this, which this file has it. And then it gives you the actual proj4 string here as well. For those of you that have worked with projections, you know it can be kind of a pain in figuring out what stuff is in. I found this has been a really nice package for transforming data. And when you get it in, you can really switch around really easily because it works. It just plays really nicely with these EPSG codes. And it makes it really simple. Okay, so we have this data. Let's look at what that looks like in our environment. So if I sort of flip on this and see what all this data is, you'll notice this is some sort of county census-based data. It has all this sort of metadata, just a regular data frame. Right, like so it's in my environment, it's just a data frame, 100 observations of 15 variables, here's all the variables. And the only thing that's different that you might notice is this geometry column that I was talking about. And you'll see it says SFC multi-polygon, and it's a list. And so if let's just look at this a little bit more. If I scroll over to the end, you'll notice this is a list column, right? So this, if any one of these row cells, if you sort of highlight it, look, it's a whole polygon. So it has a whole bunch of points in there. But it's all in one column, which is awesome because that means you can do all kinds of stuff here. You can filter this down, and it won't mess with this. It keeps this data for you, but it means that you don't have to worry about like rejoining to the spatial stuff. Or I mean, we used to do all kinds of weird stuff with like the DBF files to you'd operate on the DBF and then rejoin with the spatial, and it was complicated. So this just makes it really clean and easy. Okay, so let's go back to that vignette. This gives a few other commands that you can pull the sort of information out if you want. It just shows that this is it's a data frame, what the attribute of the list column is, and it's a geometry type. And then if you ever are interested and you want to know kind of that metadata again, you can always actually just type in summary NC, and it will give you in the summary at the very top. So it's giving me a regular summary, but if you notice at the top, oops, maybe it's not head. There we go. If you use head, it will keep this information here, reprint it for you again. So if you're ever curious how to sort of pull that back up, you can look at that. Little comment there. Regular data frame summary. Okay. All right. Sweet. So any questions thus far? This is just to demonstrate that you've got these sort of list column features at the end of these shapefiles, and they're all it's all structured the same. Anybody have that makes sense? Pretty straightforward for the most part. The other cool thing is there's a bunch of options that you can actually extract. Say you just wanted to extract the spatial data out of the data frame. You don't want any of the data. You actually just want the spatial info. There's some really nice features where you can actually do this st_geometry will give you that information. So st_geometry and then nc. You'll notice that it's sort of truncated this. Let me save this as a new, say, nc_geom. Okay, so now if let's see what this looks like. You'll notice it's a list, right? So it's pulled out the data as a list. And if I click on this, each one of these is a list of all the points for that given polygon. So you can do that. The other option, which I've found really helpful, is just pulling out the coordinates. Now this is good for XY data. It's probably best, but let's see what happens. So st_coordinates. Let's see what it gives us. Oops, I want the NC. Okay, so now what did it give me? So now it's actually giving me a vector, right, of the actual coordinates. So x, y, and then here's the sort of the grouping, right, for each one, which is kind of interesting how it's done that. So this is, again, this is really the coordinates is probably best used for x, y, for point data, right? But that's how you would pull it out really easily, which is nice. So, and then finally, the other one that I've found, particularly for polygons, which is really handy, is get the centroid points. So if we want the centroid, we can use NC. So we can pull this out as its own data, or we could add it as a point inside the data frame. And I'll show that in a minute, how to like actually just add the centroid to a set of polygons. But there's a, unsurprisingly, st_centroid command. The way they've named the functions has been really consistent, which makes it really nice to sort of look for stuff. You're like, oh, well, that's what I would call that. And guess what? That's what it's called. So, which I love. So NC. So now notice I'm just giving it, let's see what it returns. Okay, so now notice it's returned a data frame of centroids. And so if I click on this, just see what it gives, it's actually returned a entire new data frame with a new geometry column. So this list column now has a single point, the centroid point. So it's actually returned an entirely new feature. So let's plot that and see how that looks. So if we plot, the other thing is I'll show you how to do some ggplot stuff in a sec, but the plot command for SF works really well as well. With the one thing that you'll notice is if I just plot NC, this happens. And what it's doing is it's actually mapping the geometry column across every single other column in your data frame. So it's actually plotting every column in your data frame with the geometry and coloring it by the geometry, just by default. So that could be handy, but not really. Generally, you want just one unfaceted sort of map. And to get at that, we go back to the ST geometry, and we just wrap ST geometry NC inside of that plot. So now all I'm getting is that geometry, right? And then if you want to color and do all kinds of other fun stuff, you can do that. But you just want to sort of, I just want the shapefile. That's what you want. Default to mapping all columns. Just one. Okay. Now let's add. Let's go ahead and add our centroids. So we can use plot again, and now we have the what were the NC_centroid. Now again, I have to wrap this in geometry, otherwise it'll do each one. And then the other thing I can do is let's add some bells and whistles with color. Whoops, color maroon, point character equals 6. Just some plotting options. Let's make this a little bit bigger. Okay. Oh, the other thing I need to do is add equals true, right? So I'm calling another plot, but I want it to go on to the existing plot. There you go. You got centroids. Pretty sweet. So you can do this for buffering. I'll show a quick how to crop and intersect and dissolve. Like all the stuff you would do in ArcGIS, you can now do really rapidly in here. Yeah.
Just plot the first one first.
The first.
Geometry that you had.
There's only one geometry column, remember?
Sorry, I mean, did it plot when you had before it? What's all the maps in all columns?
This one?
Okay, so it just did the area.
No. So it's mapping. Let's look at the data frame again because it'll be easier to. So again, here's the data frame, right? So every single one of these columns, there's only one geometry column, right? So what it's doing is taking one geometry column and mapping that geometry across every single column in your data frame, and creating a map colored by or whatever by that each one of these columns. But there's only one set of geometry, and so by using the st geometry function, you're basically saying, I just want the geometry. I don't want any of the other stuff.
Okay.
Yeah, that's a good question. Okay, cool. Any questions on that? So I think I'm not going to walk through this, but he shows how to do some other plotting, sort of adding if you wanted to look at the a single column, like you're asking essentially, how to do that. You can also do some interesting stuff with sort of playing with the rings and grouping. A lot of different stuff is in here. Mixed geometry types. What happens when you read those in and how it sort of associates those. So I'm not going to go through this, but these vignettes are all really great and I think are worth checking out. Let's look at that one, number 3, manipulating, and then I'm going to show the example from the website. So if we go to the vignette, the third vignette, vignette 3, so now this provides some interesting things on how to convert, because the other thing is this has also been set up because the reality is you still might need to convert over to the sort of RGDAL spatial points data frames or spatial points to do certain things, right? Certain packages require that. It's really easy to convert over to that. They've made it very simple, so you can easily just do stuff in an SF, and then when you need to get to that point where you need to convert, you can do that really easily. And there's a whole bunch of functions that convert into that spatial RGDAL version. This is sort of a centroid example. Transformations, what am I looking for here? Not this at all. Let's go, oh, this is the buffering. So you can buffer, do intersections. Let's go and show an cropping sort of intersection example. And for that, let's go to the mapping in our website again. I've listed one thing, so remember we were sort of playing around with centroid and a few other things. I think it's important to remember these functions return an entirely new geometry, so a new SF object. These return an index or a matrix. And so it's actually really handy sometimes if you want to say, you want to know what points touch another polygon, right? It will actually return a vector or a matrix of that you can then use to filter your existing data, right? So it'll return a vector, not an entirely new geometry. And these are the functions that do that versus the others actually return an entirely new geometry. So let's go over to spatial data over here, this tab, and let's go to polyline and polygons. I gave this talk at, or used some of this material at the map time talk this Monday. And so the code is over here. If you click one of these buttons, you can show all code and it will show everything for you. I'm using a few more packages in here. The main one I want folks, if you want to follow along, is this USA boundaries package. I will show you how to pull it. It's really nice, and it pulls in any county state boundaries, excuse me, as SF objects, which is really great. So anyway, so what I've done is essentially, and this data is available on GitHub if you want to play with it. I have some river data that's here on GitHub at that link there. So you could just download this and put it in a data folder, and this should run. This is the OGR, this is the RGDAL way of reading in a shapefile. So I show both ways, and it's very similar. But what you'll notice is if I run this, so let me find the correct file to start. And poly, okay. So if I run the packages, and then let's load this data. What I want you to notice is how long this takes, just really quick. As an example of, I was talking about time. I've read in a gigabyte size shapefile, and it took maybe 1/10 of the time in SF versus in RGDAL. So it's significantly faster. It's not just like sort of faster, it's a lot faster. So that is reading in this, oh wait, that's not reading it in. This is reading it in. So if you were to count 1, 2, 3, it's about 10 seconds, I think, for this to read in this shapefile of rivers for California and Oregon. There's 21, almost 22,000 features. So it's a pretty rich data set. So it's still thinking. There we go, it just finished, okay? So it's like, what, 10, 15 seconds max? Now, let's see how long SF takes. You'll notice the structure is almost the exact same. It's the folder, the DSN, and the layer. So the other nice thing is they didn't switch things around a ton, so it's pretty easy to figure out if you're used to it the other way. So now, done, right? So if we said 10 seconds, that took 1 or 2 seconds. That's about 1/10 of the time, actually. So I think that in some cases is one of the greatest things. Is that writing the data is the same. It's really quick versus and reading it. Yeah.
Do you know how to fix the shapefile in the raster package?
What's that?
Do you know how to fix the shapefile command in the raster package?
I don't. I should compare do like a benchmark thing. I haven't checked that. My assumption is that it's still going to be faster because of the way it's reading the data in, because because raster is still reading in as a spatial points, right? Which that's the problem, is this, it's making lists of the way it reads it in versus the way this reads it in. I'm pretty sure this is going to be faster. Yeah, we can do a test in a sec, actually. Or well, here, let's just do it right now. Library raster, and then what is the function? Rast shapefile.
Yeah.
And then what's the? You just give it the path.
Yeah.
Rooms.
I say dot shape.
Okay. Here we go. Oh.
Thank you, library raster.
So see, I think the underlying function is the same as, it's actually using the same thing. That's what I'm pretty sure. Although this actually seems even slower than the, okay, it's about the same. So I'm pretty sure this is reading the same exact way as the RGDAL. That's a great question. Yeah.
Is there any difference in how, like, in the information that it's pulling in to justify it going so much slower?
No. They both pull in the same exact thing. I think it's just the way, again, the way that data is brought in. So let me show you, as an example, I have rivers underscore SP as my spatial, it's a large spatial lines data frame. And if we look at this, notice that the way it's structured is an S4 object, whereas data frames are like S3, so it's a completely different type of object in R. And because of that, S4 has these sort of nested lists inside of it. And if you were to try, let's click over here.
Is that RGDAL?
RGDAL, yeah. So notice the way it structures it. There's an at data, and then within that, there's the $sign for all the data frame pieces. The data frame's here, but it's nested in this at data component. And then if you notice the other information, the actual information about the lines is within at lines, and then there's in each of these, there's these really long lists. So you can imagine one of the reasons it's taking a lot longer and why it's longer to work with is because it's so nested. There's a lot more information that's the way it's being saved, right? Whereas the simple features has sort of like collapsed all of this into one thing. So there's a lot less, the size of it and the memory that it's using to sort of read that is a lot less, is the way I think the way it's working. But they're reading the exact same data. It's just the way they're storing that data in your memory. So let's look at, so for example, here's the rivers SF. So notice it has all the attributes, but again, one list column at the end that has just the segment, the line. Cool, okay. So we have that. So let's now, I want to show you really quickly this USA boundaries package. And you'll notice there's another one, there's additional data you can get for it. There's actually quite a few packages now that provide just data, and they're starting to provide the data as SF objects, which is great. So the tidy census package, I think, which has an ability to query census data really easily in R, is now bringing things in as SF objects, which is amazing because that's a really cool package. If you're interested in, I don't have a demo of that, but it's a good package. So to grab any state boundary, we just give a state name. So I'm going to say California, and then to download that into your environment, you can say high resolution, so that'll mean it's the very detailed sort of boundary line versus low, and then a state name, but you can give a whole list of states if you want. The other thing that I'm doing here is transforming, so let's take that out for a second. SF works really well with pipes is the other thing. If you use pipes, I find that they can be easy to make things pretty easy to read. So here's my California state boundary. Let's look at head of California to look at the, sorry, this. So it's a simple feature. It's a single row, right? Because it's one state, so that's it. But it's reads it in. It actually has already assigned 4326, which is just a lat long WGS84 projection. If I wanted to quickly switch that, like while I'm reading it in, I can simply use the st_transform, and then the CRS. I'm just using the same one here, but let's say, does anybody know a CRS off the top of their EPSG? What's another one? Do you remember one? What's UTM's is like, hang on, I just did this. Here's one, 32610, which is like a UTM based one. So let's find where I put it. Here we go. So all in the same command now, I can just transform this into totally different data. That's really fast. Let's look at it. Okay, so now if we look, sorry, it's printing it really oddly. You can actually get, you can check the CRS with STCRS. And it will just spit out the CRS. So now it tells me UTM zone 10 datum units are metric. There you go. So we've quickly transformed our data, reprojected our data into like different projection. Just piping that into ST transform. If your data comes in with no projection, say it's like just projectionless, you can use just this ST_CRS in the same way, and you just give it the projection you want to use, which is nice. Okay, so we can do the same thing for counties. So I'm going to use a quick example. Remember I was talking about how to assign the centroid points back to the data frame. This is using the per package to do that. Brandon Herr gave a great talk on this a few weeks ago, maybe a month ago. It's pretty neat. So here's my list of county names. Here is the command to pull the counties in. So I'm using low resolution and then the state names, right? So that's the first part. Then I am filtering to just the county names I want. So I'm pulling in all the counties for California here. So this is just California counties. And then I'm filtering, again, because these are data frames, that's the nice thing. So it's really easy to use dplyr or even just regular subsetting base R commands to filter to the county names here. So that's the second part. And then finally, I'm going to use mutate to add the centroid values. So this map_double is a per function, and it's similar to like an apply function, right? It works the same way. All it's doing is saying map the geometry column to this function here, this centroid, and then pull out the x and y. So centroid returns an x, y, right? And I'm saying, so mutate by add the long here with this, and then add the lat here with this. So it's mapping across geometry. It's mapping this function across geometry for each single one and giving me a centroid. Okay. I'm going to read this in again so that it's in lat long, just because I think that's what I need. All right. So we have that. So now let's look at our county data frame, counties spec. I don't know why I named it that, but so you'll notice we have all the sort of county level data, and then it's added my centroid here, lat long, nicely, and then it still has the geometry list column here for all the data. But really nice and clean, which is awesome. Okay. One other thing that I'm going to show is to sort of use extent or the bounding box, a way to sort of get the extent of your data, spatial extent, which is nice for mapping because you can use that down the road. So that's what this is doing, is just getting the range of the coordinates. And I'm actually pulling the coordinates out x and y and making essentially a bounding box. So if we run this, you'll see that if I look at this map range, it's literally just 4 points, right? It's the maximum lat, and then the min, and then the max and min long. Okay? So that's just one way to do that. And there are probably many ways to do that. Any questions on that? No? Okay, sweet. So let's show how to map this. So again, you've seen how to just plot this with the regular plot command, and that's all this is doing. It's going to plot our, whoops, let's make this. This is like a very awkward screen size, even though it's on. All right, so plot, there we go. So those are counties. Here is our river data. Notice it's really big. So this is, remember, this is rivers for all of California and Oregon, right? So I didn't show it a second ago. It's on the website, actually. Here we go. So this is the whole shapefile, right? And so if we plot that, we're getting this, which is actually, so remember, it's cropped to the extent my max min for this set of data. And that's what it ended up with. So that's why it's including a bunch of other rivers that I'm not really all that interested in. I'm only interested in these counties. So here's where one of the really nice things SF does is it allows us really quickly to crop or use something called ST intersection. And so two things to think about. When we're cropping in, say, an ArcGIS, for those of you that are familiar, you would have to dissolve all these counties, right, to one single boundary before you did your intersection or your crop, right? SF, you don't have to do that, which is really cool. I'm just giving it the rivers layer and then the counties layer and saying return a new rivers layer. That's it. And it will do it really quickly. I can run this over here. Here we go. So if I run this, one thing it will spit out is this little warning, which is good to think about because you want to make sure everything is in the same projection. But it says coordinates are long lat. It assumes ST intersection assumes they're planar. So you want to make sure everything's consistent. Otherwise, you might be, with different projections causing some weird stuff. So let's plot this really quick to see how it worked. And you'll notice, there you go. It really nicely cropped exactly to our county boundary. And it didn't do it for just one county, it did it for all the counties, which is also really cool. So yeah, so you can do that really easily. Say we wanted to buffer out from this, there's a st buffer command. Let's call this county buff. So we can say counties, oops, the county layer, and then it wants a distance. Now again, this is the part where it could get tricky, coding on the fly. We're in lat long, right? So we're in degrees. So let's just say 0.05. I'm totally guessing. Oh yeah, see, and it says, warning, ST does not correctly buffer long lat data, so we would need to reproject it. But let's see, did it even work? There we go. It did. So notice it buffered each county by whatever 0.05 degrees is, but like a few kilometers, I guess. But it's over. So now, and here I can. So that's pretty cool, actually, that it worked. I wasn't expecting it to work, but that's great. Let's do the original layer first. Okay, there's the original layer. And then let's make this oops. Border, white color. Okay. So there we go. There's your
Cool.
Yeah, pretty neat. So it's pretty easy to do that. Even it'll do it even if you probably shouldn't be doing that with that sort of projection, but yeah.
I was wondering before, like, say that you actually did want to crop to one of the counties in there, can you just in that same intersect command, can you just
specify
$sign for whichever one you want?
Yeah. So you want to buffer just a single county?
Yeah.
Sure. So let's say
buffer, or I was actually either way.
Yes. Yeah, you could. Because again, it's a data frame, right? So it's going to operate on, so let's try that actually. So let's say just the first county, the first row. I don't know what that is, but we'll find out. So if we crop and plot, there you go.
Cool.
So it's really easy to do that, which is really, that's what I'm saying. This is such a nice, clean way to do stuff. And I mean, I think I'm still discovering all, like, capabilities, but
So you can access it in the same way, like $equal.
yep.
You want to name the county?
Let's see. You could do, if you were to specify, yeah, let's say county name equals El Dorado. Is this uppercase or lowercase? Sorry, this doorbell's pretty funny. Keeps going off. Uppercase. All right, so try that. There you go. Yep. You can either use subsetting with numbers or $. It's a regular data frame. So everything you can do on a data frame you can do now with these spatial things. So yeah, that's really nice though, right? So that's a pretty clean, handy way to do it. Sweet, these are fun new examples I haven't played with. Start adding these to. So this website I'm gonna try to update just as I sort of figure stuff up and put it up there. So if you find things or have good examples, please send them to me and I'll put them up there. It'd be great. Because one of the things I've found is there are so many resources. It's nice to just have a place to kind of go and like look for things. And a few demos. There are starting to be quite a few good like vignettes and examples for SF, but there haven't been many for a while. Okay, so we cropped our layer. Let me re-crop this and run the plot. So now we have this nice, I've added a state line, but we've got a nice map, right? Okay. Let's do one more thing, and then I'm done. I went longer than I thought I would, sorry. I want to show you how to do this with ggplot, and also with ggmap, which allows you to put a background in your map, which is kind of cool. So important thing to note, and I need to add this on the website, ggplot has a new, the newest version of ggplot has a geom_sf function, or plotting. So it's built for SF specifically, but you have to have the newest version of ggplot or it won't work. But the great thing is when you want to do something that's an SF object, which is just, again, a data frame, this function will just take the data and plot it. You don't have to do anything fancy. It's really nice. And so it makes it really clean and easy to do a quick ggplot map. This is ggRepel, nice labels in ggplot, which I find really handy. There's geom label repel, and there's geom text repel. Text repel will literally just put the text without and under a box in the background. So now you can make nice, really, I've just sort of added a bunch of layers here, added my own fancy font, and made a map. One thing I did add, coord SF. This is where you can add your map range to just specify a certain extent. So notice in the other plots, it was plotted, the full, like a wider extent. This is actually just the extent of the counties that I'm interested in. And that comes from this map range command that I used above. And so coord SF is a nice way to clean that. So there you go. There's a really nice, clean map, right? So I want to show how to use add a ggmap background. So let me switch over to the XY data tab. And this is, I downloaded some I show you how you can scrape the website if you want, but you can just read it straight off of a, straight out of the GitHub repository. So here's the link to read this data in. And so we have to fix it because when I scrape the website, the longitude is positive, which means it'll plot somewhere in like the ocean. And so we need to make it negative. So to do that, just multiply it by -1. And then this is the RGDAL way. here's projecting. I want to get to the map part. Plotting. Okay, so here's the data. I show this example. Here we go, ggmap. I know it's in here somewhere. So a ggmap, one of the things this does is allows you to plot a whole different bunch of things with different backgrounds. There's stamen maps, Google Maps, so you can do satellite, you can do hybrid or just terrain. So this basically takes a location. I'm just using the center, like a center of the California, basically. And then I'm specifying I want it black and white, excuse me, satellite, and then the source is Google. And you can change the zoom as well to sort of change your extent. But what's nice is then you end up with Hot Springs of California with a nice black and white satellite background. Similarly, we can do this. So let's do this with our rivers example that we were just doing. So I'm literally just going to copy this chunk that we already have here, and then I'm going to add that ggmap bit at the top. Library, ggmap. And then we need to call a map, which is this, sort of, this is setting the background up. So let's dive into this a little bit more. You don't necessarily need to specify a specific centroid. You could add a bounding box or anything like that in your location. For this, let's just use the centroid. I don't know, I'm just going to guess based on the map that I already have set up. So let's say this is about 121 and can't even tell, 39.5. There are, I'm sure, better ways to do this, but for sake of just making it a quick example. Okay, so I have a location. I'm adding color, black and white, satellite. Let's change this, and let's say I actually want terrain. If I hit tab and then go over here, it'll give me anything that I want, but let's open up the help and look at what it has. It'll tell me the options. Here we go. So it tells you some information about the zoom, the value for different types of maps, and then map type. That's what I wanted to find. You can use terrain, terrain background, satellite, road map, or hybrid. All are part of Google. And then there's these stamen maps, which are really cool. I'll show the watercolor one in a second. There's terrain, watercolor, and toner. And then the source, you have to specify. These are OpenStreetMaps, CloudMate, stamen. Some of these you need an API to access. But I think stamen and Google are free to go, and OpenStreetMap. So, okay, so let's grab this. So right now we're just going to do terrain. And you'll notice that it thinks for a second, and then it says no. There we go. I didn't load the package, I guess. Okay, so now we have a background. Let's use this ggmap function to look at it. There we go. So now we have a nice terrain background. And let's add, so to add that to our existing map, all I do is start with that, and just like a ggplot, you add the pluses after it. And it should, oh, it should not actually. Here's the part, that's why I use this for a different example. So ggmap and geom.sf are not playing well together. I haven't quite figured it out, but it works. If you notice, the example I used on the website was XY data, and the call. Let's look at the command, how it's structured. Notice it's just geom point here and scale fill. So yeah, I should have stuck with that example. There's a few ways to work around that, but I don't want to really get into them right now. But you can do polygons and lines and stuff. You have to convert it to a, the fortify command to make it a ggplot option that plays well with ggmap. Anyway, now that was not a great ending, but anyway, there's that's SF, and it's great. I think it's package, and it has a lot of functionality. In the mapping methods tab over here, I'm going to build out a better page for just SF, but I recommend definitely checking out some of these other packages, like MapView uses SF objects and allows you to make interactive maps really easily with a simple just map view and the object. That's it. So actually, we could do that with our. I can salvage this example with a map view. So let's just do map view of our, what was our rivers? Yeah. That's it. So I like it because it's really simple to make a really quick, easy leaflet map. There you go. And we can zoom in. The other cool thing is it brings in all the attributes. So if you click on one of these segments, it will bring up everything. So it's a really nice way to surf through your data and like explore and play around. The other great thing is you could just share this as an HTML file with somebody if you want, so that they could check it out as well. So, and then it adds a whole bunch of layers over here, so you can change the background layers and you get really fancy and stuff like that. So, yeah, it's really easy to just throw a map in and suddenly you have something that's really nice. So, and then it gives you this little button down on the right will zoom to the extent of your data. FYI. There's a whole bunch of other cool things in MapView that I show a few demos. One of the other cool things I found is this slide view. It'll read rasters in and then allow you to make a slider window. Should have started with this stuff, I guess. Really cool because you can do this now in ArcGIS, and we've done this with some landscape or satellite imagery and photos, and it's really neat to see the differences. And now that you can do this in a leaflet, so this is a leaflet map, so I can zoom in and out and surf around just like I would in any online map. But it's it's just two rasters stacked on each other. So, and the code's in here. This is straight out of their vignette, so I didn't do this. This is just I'm showing their demo.
Is that slide view?
Slide view is the function, yeah. And then they have things like cube view, which I haven't quite figured out what you would do with something if you needed 4 maps that are all sort of surfing around at the same time. But it's cool. So anyway, MapView, it's a really nice package that's built on Leaflet. So it's using Leaflet and then giving you some fancy bells and whistles with a few functions. And it plays well with SF, so it's kind of it's a nice thing to have. Cool. All right, I'm going to stop there, and if people have questions, happy to talk, or we can just work, or whatever you want to do. See if anybody had. Oh, here's a good question from somebody online. VGMap provides static outputs. Versus Leaflet is interactive. So the nice thing with VGMap is you can save that map and send it to somebody as like a nice PDF or put it in a presentation. Wow, that's annoying. But the leaflet, you can sort of screenshot this, but it's not gonna look as good as if you made like a really nice map. I did on my website, I do show, I just wrote a few different blogs on using SF with river networks and stuff, and it's been pretty fun to see how easy it is to incorporate in some pretty fancy analysis. So I snapped points to rivers and then calculated river distance, and it's all using SF and a few other packages. But one of the other things I want to update this blog that I wrote on static maps for manuscripts. So I show this with the RGDAL package, and I haven't updated it, but all the same stuff would apply. I just need to, this is the workaround stuff I was talking about. If you want to make a fancy, nice map with a background, here's some of the different options you can use for the GG map. And then if you put that all together, you can make these, again, this is point data, but it does have a rivers layer in it, right? So it works with GG map, I promise. And then you can make an inset or, arrow bar. So this was made in R, and you could put that in a publication pretty easily. So I just want folks to know that you can use ggmap, can be good for that sort of thing if you do want to provide like a really nice high quality map. There are some stipulations depending on where you're publishing about using the Google backgrounds. So you might want to use, a lot of them will say like, no, you can't use that, or and even conferences I've heard just like they don't want people, it's weird. But just be aware of that, and if you are going to use it, maybe think about an open source like an OpenStreetMap background, which you can do as well. So, but anyway, yeah, this is kind of handy. So that's the ggmap option. I think is really nice for printing, like making nice maps like that. Leaflet's great for like exploring and sharing and putting your data up. Sweet. All right. I'm gonna stop and thank you all for being here.